So that servers are basically slide వచ్చిందన్నమాట. Are you able to see slide? So that server states that magnetic field intensity pH, that is infinitesimal magnetic field intensity pH, produced at a distant point P by a distant by, sorry, you guys able to hear me, right? Audio input లేదు అనేసి నాకు మళ్ళీ అలర్ట్ వస్తుంది. You guys able to hear me? Just give me a confirmation.
Yes, sir.
So whenever we have current carrying conductor, right? So there is a magnetic field produced around it. So what your Barrett servers says is, if you want to calculate a magnetic field at a distant point P with a current carrying conductor, then current carrying conductor which has got a differential length dl. So basically a current element is represented as I into dl, right? So it states that the magnetic field intensity pH produced at a point P by the differential current element IDL, right? Small section of the length of the conductor which is carrying current I and having a length dl, right? Just this section, not the entire section. So a small section of this, then at a distant point, right? So it is proportional to the product of IDL and the sine of the angle alpha between the element and the line joining P, right, to the element, right? That is, if you are joining this current element with the source of magnetic field at a distant point P, then it is being said that it is proportional to the product of current element, that is I into dl and sine of the angle, right? So the current element ni ఈ పాయింట్ ని జాయిన్ చేసేదైతే లైన్ ఉందో ఈ రెండింటి మధ్య యాంగిల్ ఆల్ఫా అనుకుంటే, సో ది మ్యాగ్నెటిక్ ఫీల్డ్ ఇంటెన్సిటీ ఇస్ ప్రపోర్షనల్ టు ది ప్రొడక్ట్ ఆఫ్ ఐడియల్ and sine of the angle between the current element and the line joining current element to the distant point P, and it is inversely proportional to the square of the distance r between P and the element, right? So one is, it is directly proportional to ideal sine alpha, and it is inversely proportional to the square of the distance r square, right? So the Biot servers, okay? So which is given as dH is directly proportional to ideal. dH ఎందుకన్నాము, we are taking only a small current element ideal, right? So magnetic field produced by current element IDL is dH, right? So therefore dH is equals to IDL sin alpha divided by r square. So if I'm removing this proportionality, you will have to put some constant. When the value of this k is calculated, it is coming down to 1 by 4 pi in SI units. So taking that all into consideration, this will be the expression GH, right, for DH. Now the same thing can be written in terms of a cross product, because we know that cross product of two vectors is equal to, suppose A and B are two vectors, A cross B is equals to A multiplied by B into sine of the angle between A and B, right? So if I take a unit vector AR, right, which is defined along the direction of distance r, that is line joining current element and the distance point P, then the cross product of these two, when I execute, it will be magnitude of current element IDL and magnitude of AR unit vector, right? So magnitude of unit vector is 1, and the sine of angle between these two. And sine of angle between these two is sine alpha kabatti. IDL sine alpha can be written as IDL cross AR. right? And divided by 4 pi divided by 4 pi r square. So which is equal to, you can write this as unit vector in terms of vector AR can be written as r bar by r. So therefore we will have ideal cross r divided by 4 pi r cube. Right. So this is the expression for infinitesimal magnetic field due to a current element IDM. Right. Other if I need the total magnetic field due to the total length of the conductor, then it will be equal to integration of what we have obtained here, T. Right. So H is equals to integral ideal cross R divided by 4 pi R cube. Right. So that is your Biot-Savart's law, which is giving us the magnetic field intensity due to a current element at a distant point. Right. So what we see here is, what we have to understand here is, now the direction of the current flow and the direction of created magnetic field. Right. Now when your current is flowing, say along the direction of the thumb, then a magnetic field is produced in the direction of the enclosing fingers, right? So other fingers. When you close your hand and put your thumb out, so if thumb is representing the direction of current flow, then the encircling fingers will represent the direction of magnetic field, right? So magnetic field is always around the current carrying conductor, right? So which is very, very important point to understand and remember. Okay. Now these are the different types of current distributions: line current, surface current, and volume current. So here ideal is your current element, KDS is your current element in surface charge, and JDS is the current element in your volume charge. Wherein current element, line current element, ideal I represents the current flowing through the conductor, whereas here K represents the surface current density. Right? Surface current density is equals to current per unit area. Okay. So next comes the volume current density J, which is J is equals to current per unit volume. So we have to calculate the magnetic field intensities due to these different types of current distributions, which can be done using Biot-Savart's law as well as the Ampere circuit law, which is another law which we are going to discuss now. But as we know, it is always a tedious analysis and the process to calculate whether it is electric field intensity in electrostatics or magnetic field intensity in magnetostatics using their respective first laws. Right? It is always tedious job. What I mean by that is, electrostatics లో Coulomb's law యూజ్ చేసి క్యాలిక్యులేట్ చేయాలి అన్న, magnetostatics లో Biot-Savart's యూజ్ చేసి క్యాలిక్యులేట్ చేయాలన్నా, we'll have to execute, or we have to perform very rigorous, okay, called integration, right? So usually we don't adopt that process, right? We'll go for the Ampere circuit. So for these three current distributions, the magnetic field is written like this. This is we have just discussed. So for surface current it is KDS, and for volume current it is JDV with the respective integrals. Right. So for line it is single integral, surface it is double integral, and for volume it is triple integral. Next. We have a current carrying conductor of length L, which is current carrying current I along the Z direction, and it is existing from point A to point B. Right. So in that case, if I am to calculate the magnetic field at distant point P, then first I'll have to take a small length dl, which will act as a current element IDL. So due to this IDL, first we'll try to write the expression for magnetic field at d, right? So magnetic field due to current element IDL, which is a small section of a current carrying conductor of length L, which is carrying current I, is given by CH is equals to IDL cross R divided by 4 pi R cube, where R is the distance joining the current element ideal and distant point P, and this can be written as R bar, and we can have a magnitude of R bar is equals to R. So we have this dH is equals to ideal cross R divided by 4 pi R cube. Current carrying conductor is along the z direction, therefore small length dl is equal to dz along the z direction. So dl is equal to dz az, and r is equal to rho a rho minus z az. Okay, if you are writing it in cylindrical coordinate system. So this point is rho comma phi comma 0, and this point is right. What we call 0 comma 0 comma 5 comma z, because ఇక్కడ radius is 0, ఇక్కడ radius is rho, right? Radius of cylinder, which is the perpendicular distance measured from z axis. So if we assume this point P is at a distance of rho from z axis, then rho will become the radius of the cylinder, which is consisting of this point P, right? So the vector from here to here, P to ideal can be written as destination point minus source point, and destination point is rho comma phi comma 0, and the source point is 0 comma phi comma z. So you'll have rho minus 0 a rho bar, phi minus phi 0. So and then we'll have this as 0 minus z a z bar. So it is rho a rho minus z a z bar. So all that we got to do is I dl cross r, right? So I is a constant value కాబట్టి we don't have to worry about it. Now your dl cross r bar చేయాలి కాబట్టి dl cross r bar, that is determinant cross product execute చేస్తే we will have it as rho dz a phi, right? So ఎలా execute చేస్తారు? Rho a rho a rho a phi a z, right? So then we'll take it as dou by dou rho, dou by dou phi, dou by dou z, and then finally we'll have it as magnitude of rho and magnitude of z in the last row. Now, wherever you have got phi component, right, whether it is magnitude of phi or whether it is a unit vector in phi direction, we'll have to put rho, right? Radius పెట్టి చేయాల్సి వస్తుంది. ఓవరాల్ గా కూడా డిటర్మినెంట్ కి ముందు కూడా 1 by rho అని పెట్టి చేసుకోవాల్సి వస్తుంది, right? So determinant execute చేస్తే మనకు rho dz a phi వస్తుంది. Okay, so once we have this, we substitute it here. It is I into dl cross r is written as rho dz a phi and divided by 4 pi into r. R is the magnitude of this vector, so it is root of rho square plus z square, which can be written as rho square plus z square to the power of 3 by 2, right? So ikkada what we do is we join these other ends of the conductor to the distant point P, and we define an angle alpha 1, alpha and alpha 2 with respect to z axis, right? So you have a right angle triangles for every angle alpha 1 P. This is the right angle triangle AOP, right? For alpha, the right angle triangle is ఇక్కడ పాయింట్ ఏం పెట్టలేదు కాబట్టి క్యూ అని అనుకుంటే QOP, right? It is the right angle triangle for alpha 2 is POP. So అవన్నీ పెట్టేసుకొని if we take cot alpha, we will have it as z by rho, so z is equal to rho cot alpha. I think we have taken in class tan alpha తీసుకొని చేసినట్టున్నాము. So either way we can do. Tan alpha చేస్తే ఇక్కడ secant square alpha వస్తుంది, cot alpha చేస్తే ఇక్కడ cosecant square alpha వస్తుంది, right? So right. నాకు గుర్తుండి కూడా మనం క్లాస్ టైం చేసామంటే ఇక్కడ యాంగిల్స్ తీసుకున్నప్పుడు మనం ఆల్ఫా 1 ఆల్ఫా ఆల్ఫా 2, సో ఆల్ఫా 1 ఆల్ఫా ఆల్ఫా 2 అని తీసుకుంటే ఈ డిస్టెన్స్ తీసుకోవడానికి tan ఆల్ఫా తీసుకోవాల్సి వస్తుంది. అదే ఇక్కడ యాంగిల్స్ తీసుకుంటే ఈ డిస్టెన్స్ కావాలి అంటే cot alpha తీసుకోవాల్సి వస్తుంది. So we have this, we substitute the values of pz and z in the above expression. So it is rho square cosecant square alpha, d alpha divided by rho cube cosecant cube alpha. Now when we cancel out these terms, we will end up with 1 by rho cosecant alpha. So 1 by cosecant alpha is sin alpha, so integration to Integration of sine is minus cos, so minus minus plus cos of alpha to minus alpha 1, and we substitute this, and we substitute the limits, right? Now, when you actually extend this length of the conductor, right? So when you make it as infinite above and below, that is both the answer of at infinite points, then the angles will come down to 90 degrees and alpha 2 is equals to 0, right? One is 90 and one is 0. So when we substitute this in this expression, for infinite length we are having which is equals to 1 by 4 pi rho a phi, right? So sorry, one point is at 0, that is origin. A point is at origin. B is at infinite. Then these are the angles. If A is at infinite, that is completely negative, and B is at the positive infinity, that is completely above. Then the angles will come down to 180 degrees and then alpha 2. Alpha 2 is equal to 0. So overall magnetic field intensity is 1 by 2 pi rho A phi, right? So if you're taking infinite length on only one side, ఏదైనా ఒక సైడ్ తీసుకుంటే the magnetic A point కానీ B point కానీ ఏదైనా ఒకటి infinite దగ్గర తీసుకుంటే the value will come down to 1 by 4 pi rho A phi. If you are taking A and B at infinite, that is one is at minus infinity and the other one is at plus infinity, the angles will be equal to 180 degrees and 0 for this arrangement. The arrangement of 180 degrees and 0, right? If I am making this as completely what you call infinite చేసినప్పుడు ఏమవుతుంది, where alpha is the angle measured from this line to current element, right? So current element measure చేస్తున్నాం కాబట్టి కంప్లీట్ గా మీకు ఇది వర్టికల్ ఇలా స్ట్రైట్ లైన్ లాగా అయిపోతుంది. సో స్ట్రైట్ లైన్ అన్నప్పుడు when you measure that, it will be nearly 180. ఓకే, అదే ఇది వచ్చేటప్పటికి ఏమవుతుంది, ఇది పైకి వెళ్ళిపోతుంది కాబట్టి ఇది this will be like a very close line, right? ఇది 0 అయిపోతుంది. ఈ అరేంజ్మెంట్ కి 180 0 వస్తుంది ఫర్ ఫుల్ ఇన్ఫినైట్. ప్లస్ అండ్ మైనస్ ఇన్ఫినిటీ వరకు ఎక్స్టెండ్ అవుతుంది. మనం తీసుకున్న యాంగిల్స్ ఎలా ఉందంటే ఇక్కడ ఉంది. సో అవేమవుతాయి అంటే ప్లస్ 90 మైనస్ 90 అని మారిపోతుంది, right? So for this arrangement it is 180 and 0. For the arrangement that is the side of the angle that we have taken, for that it will be plus 90 and minus 90. Okay, so ఎలా తీసుకున్నా కూడా for infinite length from minus infinity to plus infinity, the value of magnetic field will be equal to 1 by 2 pi rho A phi. Okay, whereas here for any one side is up to infinity, then it is 1 by 4 pi rho A phi, right? So same things can be obtained using Ampere circuit law also, right? So which says basically whenever there is a current flowing through a conductor, then there is a magnetic field around it, right? So if you are taking all those points on the circular path, so if there is a current carrying conductor, we create a closed path around this conductor, then the integral of line integral of magnetic field on all these, the line integral of magnetic field on this closed path will be equal to the current enclosed by the path. కండక్టర్ ఉంది, దీని నుంచి కరెంట్ ఫ్లో అవుతుంది, దీని చుట్టూ ఒక క్లోజ్డ్ పాత్ అజ్యూమ్ చేసి ఆ క్లోజ్డ్ పాత్ మీద ఉన్న అన్ని పాయింట్స్ దగ్గర మ్యాగ్నెటిక్ ఫీల్డ్ ని యాడ్ చేస్తూ, రైట్? దట్ ఈస్ యువర్ ఇంటిగ్రేటింగ్ బేసికల్లీ. ఈ క్లోజ్డ్ పాత్ మీద ఉన్న మ్యాగ్నెటిక్ ఫీల్డ్ ని యాడ్ చేస్తే, రైట్? సో ఆల్ పాయింట్స్ దగ్గర మ్యాగ్నెటిక్ ఫీల్డ్ ని యాడ్ చేస్తే దట్ ఈస్ యువర్ బేసిక్ ఇంటిగ్రేషన్. దెన్ ఇట్ ఈస్ ఈక్వల్ టు ది current which is enclosed by this path అనేసి Ampere circular is telling us, right? So properly Ampere circular states that the line integral of tangential component of magnetic field intensity H around a closed path is the same as the net current I enclosed by the path, right? So integration of tangential component of magnetic field is equal to the current enclosed by the path at which you are integrating the magnetic field. Okay. So that is line integral, closed line integral of H dot dl is equal to I enclosed. So as it is a closed line integral, we can apply Stokes theorem and convert it into surface integral. So line integral of h bar dot dl can be written as surface integral of del cross h, which comes from Stokes theorem. Suppose line integral is converted into surface integral of curve. Okay. So we have I enclosed is equal to surface integral of del cross h ds. Right. So LHS key value HSCD, RHS equation of the current. We know that current can be as integration of current density, because current density is equals to current per area. So current is equals to current density into area. If we are having differential current element, then we can calculate total current element from surface integral of current density, right? So I enclosed is equal to surface integral of J ds. So equating these two will give us del cross H is equals to J, right? So here del cross H is equals to J. What it tells is that the cross product del cross of the vector H is not equal to 0. That means it is not a conservative field, right? Whereas in static electric field we have seen that del cross E is equals to 0, and we said E is conservative. It is not the case with your magnetostate. Del cross it is not equal to 0. So we can apply this Ampere circuit law to calculate the magnetic field intensities of different current distributions very conveniently. So first we take a line current, right? We created a closed path around it, and if we are to calculate magnetic field at a distant point P, then this closed path is chosen such that the P lies on that closed path, right? So now applying Ampere circuit law, E is equals to I enclosed by the path is equals to line integral of h bar dot dl. So for that, h exists. H is around this conductor, which is a circular path. So circular path is this phi direction. So H is in phi direction. Therefore, H bar dot dl diameter H bar place to H phi A phi, because phi H is in phi direction. Then what we call DL is also should be considered in phi direction. So along the phi direction, the dimension is always along the any angle direction, the dimension is always radius into angle, so it is rho into d phi, right? So taking dot product, we will end up with h phi rho d phi. So h phi is constant, integration is with respect to 2 phi, and the limit of phi is from 0 to 2 pi, right? So integrating it, you will end up with 2 pi. So h pi rho into 2 pi. This is your h bar. Right? So since we have taken only one straight conductor carrying current, it is h pi is equals to I divided by 2 pi rho, right? And since it is in phi direction, finally we can put phi unit vector here. If we have got n number of conductors, then you would take this as h is equal to n into I. Okay. Now we see that h is equals to I divided by 2 pi rho into a phi if n is equals to 1, which is the same value that we have obtained for an infinite length of conductor using Biot-Savart. So I don't need to put the same expression. Okay. So again, this Biot-Savart Ampere circuit law is convenient to be applied for infinitely large current distributions, right? If it is a finite current distribution, then it's what we call length is not in the consideration, right? So for a limited length of the conductor, we should always use Biot-Savart's law. Same with your electrostatics also, right? If it is a limited length of line charge distribution, we have to take Coulomb's law. So infinite lengths ఉంటే conveniently Gauss law కానీ Ampere circuit law కానీ యూజ్ చేసుకోవచ్చు in static electric field and static magnetic field respectively. Otherwise, we'll have to use, if it is infinitely large, we have to use only these. So that's it for today. Yeah, let's go to another 1.5 minutes. Bashman, did you take attendance? Because earlier it showed me around 27. That means 25 students were present, excluding few of my life.
Sir, when I have taken the strength was around 25, sir.
And,
25 when I have taken.
25 అంటే 23 కాంప్లెక్స్ వస్తుంది
అవును.
ఎందుకంటే 2 ఉంటాయి.
ఈవెన్ లాస్ట్ స్ట్రెంత్ కూడా లాస్ట్ క్లాస్ లో కూడా స్ట్రెంత్ ఇంతే ఉండదు.
ప్రాబబ్లీ ఒక రూల్ పెట్టాలి, అటెండెన్స్ మెయింటైన్ చేయని వాళ్ళు ఆన్లైన్ లో ఫైనల్ ఎగ్జామ్స్ పెట్టేటప్పుడు ఇంత అటెండెన్స్ ఇంత కన్సిస్తుంది, అండ్ దాట్ అమౌంట్ షుడ్ బి అ లార్జ్ నెంబర్, రైట్? సో నీట్ యాజ్ ఆల్రెడీ అప్పుడు ఆటోమేటిక్గా వచ్చేస్తారు అందరూ. జెన్యూన్ రీజన్స్ ఉన్న వాళ్ళు తప్ప మీకు anyhow, okay, then that's it for today. Next session we'll discuss this.